Chapter 7, Lesson 4, Scale Drawings. You will be able to solve problems involving scale drawings. Scale drawings and scale models are used to represent objects that are too large or too small to be drawn or built at actual size. The scale gives the ratio that compares the measurements of the drawing or model to the measurements of the real object. The measurements are proportional to the measurements on the actual object. What is the actual distance between Hagerstown and Annapolis? So we have our scale down on the bottom, and the first thing I'm going to do is start by writing that scale. 1 centimeter over 24 miles, and I'm going to write it as a fraction. I will eventually be setting up a proportion, so I'll start that over there. Before I know what to fill in here, I need to know the measurement on the map. So we have the city here to Annapolis over here. And let's measure from the center of the dot to the center of the dot, roughly. It looks like 4 centimeters. Now the 4 centimeters would go on top to match the other centimeters on top, which means our unknown is in the denominator. From here, let's cross multiply. 1x equals 24 times 4, which is 96. Divide by 1. X equals 96, and the unit we're missing or need to find is miles. So the two towns are 96 miles apart. Letter B. On the map of Arkansas shown, find the actual distance between Clarksville and Little Rock. Use a ruler to measure. Oops. So here's Clarksville and Little Rock. Let's use our ruler here. Okay. Our scale on the bottom is 1 centimeter equals 20 miles. So I'm going to write that as a fraction and set up a proportion. We measured the distance with our ruler to be 4 centimeters, and our unknown would go in the denominator. Cross multiply. 1x equals 80. Divide by 1. X equals 80 miles. A graphic artist is creating an advertisement for this cell phone. If she uses a scale of 5 inches to 1 inch, what is the length of the cell phone on the advertisement? So we have 5 inches to 1 inch, where 5 inches would be our advertisement, and 1 inch would be the actual. Now the actual length of the cell phone is 4 inches, so we're going to line it up in the denominator with the actual amount, and our unknown being in the numerator. Cross multiply. 1x equals 20. Divide by 1. X equals 20 inches. A scooter is 3.5 feet long. Find the length of a scale model of the scooter if the scale is 1 inch equals 3/4 feet. So 1 inch over 3/4 feet. We're given the actual amount, which is 3.5 feet, and I'm going to change that to an improper fraction, which is 7/2. So 7/2 feet, leaving our unknown in the numerator. Cross multiply. We get 7/2 equals 3/4 x. To get rid of a fraction, we multiply by the reciprocal, which is 4/3. And we get 28/6 equals x. Well, let's take 28/6 and simplify it here. It would go in, 6 would go into 28, 4 times with 4 left over, which reduces to 4 2/3 inches. A scale written as a ratio without units in simplest form is called the scale factor. Find the scale factor of a model sailboat if the scale is 1 inch to 6 feet. We're going to start, of course, still by writing 1 inch over 6 feet. Now, we want to convert it so it's the same unit. It's easier to take your bigger unit and make it smaller. So I'm going to multiply here. I want to get rid of feet, and I want to change it into inches. Well, there is 1 foot and 12 inches. What happens here is both sets of units cancel out, which is exactly what we want to happen. So 1 times 1 is 1 over 6 times 12, which is 72. So your scale factor is 1/72. No units. Letter B. What is the scale factor of a model car if the scale is 1 inch equals 2 feet? Start by writing that as a fraction. And again, we're converting feet to inches. We want to get that 2 feet in inches. There's 1 foot over 12 inches. Again, the units cancel out, and we are left with 1 over 24. A floor plan for a home is shown below, where 1/2 inch represents 3 feet of the actual home. What is the actual area of bedroom 1? So let's look at bedroom 1. We need to find the length and the width in feet. So let's start with our scale factor, or our scale, excuse me. 1/2 inch over 3 feet equals. Well, we'll do our width here, 1 inch over x. Cross multiply. 1/2 x equals 3. Multiply by that reciprocal to get it away from x. So multiply by 2 over 1. And we get x equals 6 feet. So I know the one measurement down here is 6 feet. Now let's convert the 4 inches. Start with your scale, 1/2 inch over 3 feet equals, this time 4 inches. I'm going to use a different variable, y. Cross multiply, 1/2 y equals 12. Multiply by that reciprocal to get y by itself. So multiply by 2 over 1. And we get y equals 24 feet. So this measurement is 24 feet. To find the area now, we have both dimensions. To find the area of this rectangular bedroom, we use the formula area equals base times height. Area equals our 6 feet times the 24 feet. So let's figure out 6 times 24 is 144. So 144 square feet. Letter D. What is the actual area of bedroom 3? So bedroom 3 is on this side. Oops. It looks like we have 1 inch again, which, don't do the math twice, I know is 6 feet from my earlier question. But now let's convert that 3 inches. Using the same scale, 1/2 inch over 3 feet equals We're converting 3 inches, and I'm going to use a different variable. We'll use z over z. Cross multiply, 1/2 z equals 9. Multiply by the reciprocal to get your variable by itself, and we get z equals 18 feet. So this measurement is 18 feet. And again, to find the area, we multiply the base and the height. Area equals, the base is 6, the height is 18. So 6 times 18, which is 108. So 108 feet squared.